I'd like to end this video with an example of the sort I like to introduce the first day in our finite math classes. In that course, the first chapter is concerned with applications of linear functions to simple business situations. And this is, I think, a great way to break the ice on that. So, even in this course, well, let's say that we run the widget corporation, or the widget company. All right, everybody knows what widgets are, right? Now, this is a very small company. It's a small operation, and we have a small building. It has, lights, air conditioning, electricity, water, rent, and let's say that the overhead costs are $1,500 per month. In finite math, we call that the fixed cost. It's fixed regardless of how many widgets you make. Now, what I call the unit cost is what it costs to make a widget. And the cost per widget is $40 per widget. Now, that little Latin word per means to divide by, or sets up a ratio, $40 per widget. We're going to see that this is the slope of our line here in a minute. But I don't want you to take my word for it. I want you to see why it is a slope. You'll learn something from that. All right, now what I'm after is, well, what does it cost to make a certain number of widgets? Now, to form this equation, or this function that describes cost, I need a variable, and let's call it x. So let's let x be the number of widgets. All right, so I'm after the cost of making x number of widgets every month. All right, that's what we want to model. This is a mathematical model, incidentally, an example of one. Well, to get at this, let's look at the graph. We can kind of graph this out. And so, and for my horizontal axis, I'll use x. X is the number of widgets. Number of widgets. And I'm going to think of that as my input. The input into my cost function is number of widgets. The output is going to be the cost, which is going to be measured in dollars. And so cost would be dollars. Now, if you make 0 widgets, which sounds kind of silly, but if you made 0 widgets, what's the cost of running this company? Well, you didn't spend anything making widgets, but you still have the building to account for, $1,500. So the cost would be $1,500, and that's right here. So guess what? That's the fixed cost ends up being the y-intercept to our function, to our equation. All right, because the y-intercept is always where x equals 0. And if you make nothing, you're still going to spend $1,500. Now, suppose that we make, what's a good number? 50 widgets. 50 widgets this month. All right. What's the extra cost on top of the fixed cost? All right. Now I need some room here, so I'm going to have to do some erasing. The extra cost is above the fixed cost. In finite math, we call that the variable cost. This is the cost that varies according to the amount of widgets you make in this case. All right, so if I made 50 widgets and I multiply this by the per unit cost, $40 per widget, now look what happens here. I'm going to multiply these two fractions. I'll put that over 1, and the word widget appears as numerator and denominator. So this may be totally new for you. I'm going to really hammer home throughout this course in word problems the role of these words, these units such as widgets or dollars. And once you understand how to use units, those word problems are going to be somewhat easier for you. Okay, that's the good news. All right, so if you have the patience for this, then you're going to get a lot better at word problems than you ever thought you could be. All right, well, what happens here is the widgets cancel, and that's good because this gives me dollars. So all I have left are dollars. And how many dollars? 50 times 40 is $2,000. $2,000. So when I make 50 widgets, we add an additional $2,000 in cost. So now $2,000 in cost would be, right up about here. So it would be $3,500 total, wouldn't it? Okay, so 50 widgets, total cost is going to be the fixed cost of $1,500 plus the other $2,000 for making 50 widgets, total of $3,500, and that's up here. So if we connect these dots, there's our line. Now I didn't extend my line to the left because in this case it makes no sense to consider negative number of widgets. So in a real problem like this, you would probably just draw a ray rather than a line. Well, all right. Now if you look at the slope of this line, if you accept these 2 points, and we've made the assumption that this problem is so simple, the cost is rising according to a straight line, then we can think about the slope values here. What is the change? Well, the vertical change goes from $1,500 to $3,500. That's an increase of $2,000. And the horizontal change runs from 0 to 50. 50 what? 50 widgets. So according to the way we calculate slope, and let me make some room up here. The slope of this line is going to be the vertical change, which is a positive 2,000, divided by the horizontal change, 50 widgets. And if you simplify that, divide 50 into 2,000, guess what? You get $40 per widget, which was the unit cost. So the unit cost was a slope value, $40 per widget. You're going to find a lot of familiar things in life show up as slope numbers. For example, you drive your car, your speed is measured in miles per hour, miles divided by hours. That's a slope calculation. The miles per gallon, that's slope. Your wage, if it's calculated in dollars per hour, that's a slope calculation. So slope shows up in a lot of areas of life without you may not have ever realized that. All right, now while we're at it, let's go ahead and finish this problem. Now, the cost of making X widgets is going to be the slope, $40 per widget, times X widgets. Widgets cancel, so it's 40X plus the y-intercept of 1,500. So let me kind of outline this cost equation. All right, that will calculate for you the total cost of this operation of making X number of widgets. Very easy to verify that it would match this line by plugging points in. Well, and I've written it as a function, which you just learned about recently. And functions have inputs and outputs. So my input value is the x-axis, the output value is the y-axis. In this case, I call it cost. So there you go, a linear function. And it has slope times x plus y-intercept.